Today we're going to talk about integral exponents. So we'll start with our definition. What is an integral exponent? Well, that looks like the expression a raised to the n power. A represents the base and n represents the exponent. So a raised to the n power means you're going to take a and you're going to multiply it to itself n times. For example, 3 to the 5th would be 3 times 3 times 3 times 3 times 3. 3 multiplied to itself 5 times, which would give us 243. Now pay attention with negatives. Negative 2 to the 5th would mean you're taking negative 2 and multiplying it to itself 5 times. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. A negative raised to an odd power will be negative, but a negative raised to an even power is going to be positive. So negative 2 times itself 5 times would give us negative 32. Now there's a bunch of properties that go along with these integral exponents. So we're going to let a and b be real numbers, and m and n are going to be positive integers. The first property we're going to talk about is a to the m times a to the n. Like bases being multiplied, you're going to add their exponents. So that would become a to the m plus n. For example, 3 to the 5th times 3 to the 3rd would be 3 to the 5 plus 3, or 3 to the 8th. And you can check this yourself. 3 to the 5th power is 243. 3 to the 3rd power is 27. 3 to the 8th power is 6,561. And if you take 243 and you multiply it by 27, you'll also get 6,561. The next property we're going to talk about are like bases being divided, a to the m over a to the n. You'll subtract their exponents, the numerator exponent minus the denominator exponent. For example, 3 to the 5th over 3 to the 3rd would be 3 to the 5 minus 3, or 3 squared. Well, 3 to the 5th is 243. 3 to the 3rd is 27, and if you take 243 and divide it by 27, you will get 9, which is 3 squared. Now the next two properties go along with if you have an expression and that expression does not have addition or subtraction, you can distribute the exponent. So the first one is multiplication. A times b to the n, you can distribute that exponent, a to the n times b to the n. So 2 times 5 to the 3rd would be 2 to the 3rd times 5 to the 3rd. Well, and you can check that. 2 times 5 is 10, and 2 to the 3rd is 8, 5 to the 3rd is 125. 10 to the 3rd is 1,000, 8 times 125 is also 1,000, so it works out. This property, that if you don't have addition or subtraction and you can distribute the exponent, works for division as well. A over b to the n, you can distribute the exponent, that's a to the n over b to the n. So 4 over 3 squared would be 4 squared over 3 squared. Well, remember what it means to square something, you multiply it to itself. So 4 over 3 squared would be 4 over 3 times 4 over 3. Well, multiply across, you get 4 times 4 is 16, 3 times 3 is 9, which is 4 squared over 3 squared. The next property is power of a power. If you have an expression that's being raised to an exponent and you raise it to another exponent, you multiply the exponents. So 2 to the 3rd squared would be 2 to the 3 times 2, or 2 to the 6th. Well, 2 to the 3rd is 8, 8 squared is 64, and 2 to the 6th is 64, so it works out. Next, anything raised to the 0 power is 1. A lot of people think it's 0, but it's not. A to the 0 is 1, and I will show you. For example, if you had 6 to the 4th over 6 to the 4, remember from a previous property, like bases being divided, you subtract their exponents. So 6 to the 4th over 6 to the 4th would be 6 to the 4 minus 4, or 6 to the 0. Well, 6 to the 4th is 1,296. So 1296 over 1296, when you have something over itself, it reduces to 1. So as you can see, 6 to the 0 is equal to 1. Few more properties. The next couple we're going to talk about negative exponents. Anything to the negative exponent. You cannot take a and multiply it to itself a negative amount of times. So you're going to have to get rid of that negative exponent. To get rid of a negative exponent, you move it to the opposite side of the fraction bar. If it's in the numerator, you bring it down to the denominator. So a to the negative n would be 1 over a to the positive n. So 5 to the negative 3rd, you would bring that negative exponent down. It would become 1 over 5 to the 3rd. And then 5 times itself 3 times would give you 1 over 125. If that negative exponent is in the denominator, you bring it up to the numerator. 1 over a to the negative n would just be a to the positive n. So if you had 1 over 3 to the negative third, you would bring the exponent up to make it positive. It would be 3 to the positive third, or 27. And finally, the last property we're going to talk about is a over b raised to the negative n power, a fraction raised to the negative power. All you have to do is take the reciprocal. Instead of a over b, it would be b over a, and then you would get a positive exponent n that you could distribute using properties from before. So if we had 5 over 2 to the negative fourth, using a previous property, you could distribute that exponent, 5 to the negative 4 over 2 to the negative 4. The last two properties we went over, 7 and 8, said negative exponents, you move to the opposite side of the fraction bar. So we'll bring the 5 to the negative fourth down and the 2 to the positive fourth up to get 2 to the fourth over 5 to the fourth, which gives us 16 over 625. Now all the examples I showed you were with integer bases. These work for all sorts of bases, and so now what I want you to do is work through the problems in the rest of this packet and do all these properties and apply them to variable bases.